Hey everyone, and welcome to today's Explainer. We've got a really cool and honestly super important topic to dive into today. We're looking at our official lesson, and bear with me here is the official tag. Lesson ID, STEM AI, Unit 02, Lesson Pack 02, Reasoning Source-Based Model Video Overview. And the exact title is Reasoning Source-Based Model Video Overview. We're right in the middle of Unit 2, focusing on representation and reasoning. I am so pumped to get into this because by the time we wrap up, you're going to see artificial intelligence in a totally different light.
All right, so here's our game plan for today. First up, we're tackling the misconception. Second, we'll look at the evidence. Third, we've got a worked example. And finally, we'll finish things off with the transfer task. So let's jump right into Section 1, the misconception, or as I like to call it, the trap of because the AI said so.
You know, when we first start messing around with AI, it kind of feels like magic, right? It types out these answers with such absolute confidence. But that actually leads us straight into a really dangerous misconception. A lot of people assume, hey, if an AI model generates a conclusion, it must be valid, and any data it found online is equally trustworthy. Let that sink in for a sec. How often have we just assumed that because a computer spat out this perfectly written paragraph, it has to be true? Or that whatever random website it scraped is just as reliable as a peer-reviewed science paper? It's a super relatable trap to fall into, but it is dangerously wrong.
Which brings us to a huge, glaring question. Wait, is all data equally trustworthy? Really think about that. If I scribble a random thought on a sticky note and slap it on a wall, is that suddenly just as trustworthy as a massive official government report? Well, no, obviously not. And as we're going to see, AI doesn't just magically turn bad data into good data. That takes us to Section 2, the evidence. This is all about building trustworthy reasoning. We're not just going to guess how AI works here, we're actually going to look at the official frameworks to clear up this misconception. First, let's check out what the experts at OECD.ai have to say. They explain that an AI system really has three main parts. First, you've got sensors that collect raw data inputs from the environment. Second, there's the operational logic. That's what interprets the data to figure out an objective. And third, the actuators. Those actually provide the output or do the action. Now, the absolute most crucial part here, that operational logic in the middle, it relies totally on the raw data those sensors collect. If the sensor feeds the system straight-up garbage data, well, the operational logic is going to interpret that garbage, and the actuator is going to output a garbage recommendation. The quality of the input data literally changes the output entirely. And you know, this is exactly why the NIST AI Risk Management Framework, or RMF for short, even exists. This NIST playbook tells us straight up that we can't just blindly trust AI. It's meant for voluntary use to help organizations manage AI risks and literally build trustworthiness right into the design and use of these systems. The big takeaway here is that trust isn't automatic. Cultivating trust means we have to actively map and measure risks, kind of like a detective looking for clues, specifically by evaluating the data the AI is using, because if we don't evaluate that data, we can't protect individuals and society from some really bad decisions. So how exactly do we evaluate that data? Well, the AI for K-12 guidelines give us a super clear path under Big Idea 2, which focuses on representation and reasoning. To build a valid, source-based reasoning model, we've got to follow 4 specific steps. Step 1. Identify the claim the AI is making. Step 2, locate the source, like where did the AI actually get this information? Step 3, judge the reliability of that source using that NIST framework mindset we just talked about to measure the risk. And step 4, connect that evaluated evidence back to the conclusion. If the source is bad, the conclusion is invalid, period.
All right, let's see this in action with Section 3, the worked example. We're going to look at a simple classroom scenario.
Imagine you're doing research for a 7th grade project, and you decide to use an AI tool to grab some facts. Listen to the difference between these two statements. First, we have a weak claim. The AI says a new video game makes you jump higher. Okay, now compare that to a source-backed claim. The AI cites an OECD report showing specific physical activities increase jumping reach. Both of these might pop out of an AI chat window, but remember our huge misconception from earlier? Just because the AI generated the text doesn't magically make it valid. We actually have to check the trustworthiness of the source backing it up.
Let's apply our 4-step process to that weak claim and see what happens. Step 1. Identify the claim. The claim is that a specific video game increases your physical jumping ability. Step 2. Locate the source. We dig into the AI's output and realize, oh, it pulled this fact from some unverified anonymous online forum post. Yikes. Step 3. Judge reliability. Using the NIST AI RMF playbook, we map and measure this risk. An anonymous forum post that is incredibly high risk and totally fails the trustworthiness check. Step 4. Connect to conclusion. Because the source is completely unreliable, the reasoning changes breaks. We have to reject the AI model's reasoning here. Its operational logic was literally fed bad data.
Now for Section 4, the transfer task. This is where it's your turn to try it out.
I'm handing the reins over to you now. I want you to apply this exact same source-based reasoning process to a totally new scenario, one that's actually inspired by a real-world example from the OECD.ai documentation. Imagine an AI credit scoring system. Its main objective is to decide whether to approve or deny a bank loan. This AI denies a person a loan, and when we check its reasoning, we find out it based its decision on a random, anonymous blog post it found online complaining about the applicant's town. So, how do we evaluate this reasoning? I'll give you a second to mentally run through our 4-step process.
All right, let's break down the solution step by step. Step 1, identify the claim. The AI's claim here is that the applicant is too risky for a loan. Step 2, locate the source. The data input is that anonymous blog post. Step 3, judge reliability. Apply the NIST framework. Is an anonymous blog a trustworthy source for someone's financial risk? Absolutely not. It is highly, highly unreliable. Step 4, connect the conclusion. Because the data is bad, the AI's operational logic is fundamentally flawed. See, treating all data as equal leads to terrible, real-world consequences, like someone unfairly losing out on a loan. The reasoning chain is completely invalid.
And that brings us to our final and honestly most powerful takeaway for today's explainer. AI reasoning models and conclusions are only as good as the trustworthy evidence behind them. That right there perfectly captures AI 4K12's big idea too about representation and reasoning, as well as the core of the NIST framework. So next time an AI gives you a super confident answer, do not just accept it because a computer said it. Check the sensors, find the source, and ask yourself, is this actually trustworthy? Because if AI is learning from us, what happens to our future if it's relying on our absolute worst, most unreliable data? Think about that for a bit. Keep questioning, keep verifying, and I'll catch you in the next explainer.